Okay, this is the next page in your journal. Your title is Pythagorean Theorem. The Pythagorean Theorem is a formula that says a squared plus b squared equals c squared. And it only works for right triangles. Okay, so I'm going to draw, and you're going to copy me, a picture of a diagram so you can understand how they got this formula. Okay, so you need to scoot down a little ways because you're going to need room all around your right triangle. So come down here. You want to make this side like 3 lines long, 1, 2, 3, and then we're going to make this one be a little bit longer than that side. Okay, probably like that. And so here's going to be your right angle, and draw out that side. Okay, so the Pythagorean Theorem has these special names for the sides. So the sides that form this right angle, these right here, these two, are called the legs. And then across from the right angle will always be the hypotenuse. Okay, so we're going to draw squares around the side of this right triangle. And whenever we wrote out the formula, you heard us say a squared plus b squared. So whenever we say squared, we're actually talking about squares. Okay, so the side of the triangle on this leg, you need to draw it out. And if it's not perfect, that's okay, because mine's not either. But try to make it look square-ish. And then do the same thing on the other leg. Looks squarish. And then you're even going to do the same thing across the hypotenuse. It's okay if you run over your words a little bit. Okay. Now you have to divide your squares up into units so I can show you where this formula is coming from. So this side that you made 3 like lines wide, you need to draw it like this. So that means it's going to be 3 lines across, up and down like this. So it's a square that's like 3 across the top and 3 across the side. This one's going to have to be 4 by 4. It's okay if it's not perfect. Just try. So this one needs to be 5 by 5. Okay, now you should have 2 different highlighters. It doesn't really matter what color, but what I want you to do is you'll number these with 1 color. Okay, so what you're really showing is that the area of this square is 9 units. Okay, 9 square units over here. I'm going to use my other color highlighter, and I'm going to get the area of this square. Okay, so since it was 4 by 4, 4 times 4 gets you the area of 16 square units. So I've got 9 square units and 16 square units. So this very magical thing is about to happen. The area of this side of a right triangle, the hypotenuse side, this area is always going to be equal to the sum of the areas that are attached to the legs. Okay, so to prove that, I'm going to number 1 through 9 with this color. Okay, so I'm just showing that this area is filling up this space on that biggest square. And then I'm going to number now with these over here to show that really the rest of this area is equal to this one. So this was 1 through 16. Okay, so there's your proof that for every right triangle, if I have the area of the square attached to this leg, and I add the area of the square attached to this leg, it is always going to be equal to the area attached to the hypotenuse. That's the longest side over here. Okay, so now I'm going to label a little bit. So I called this a leg, and I'm going to call this one leg A. I'm going to call this one leg B, but A and B are interchangeable. This side does not always have to be A. It can be a B, okay? But the thing that you can never change is that this longest side across from the right angle is always the hypotenuse. And it is labeled as C. Okay, so that's why the formula says if I take this side A, so that was like a 3, and I do 3 times 3 because it said A squared, and I add this side, this length was B. Whenever I do B times itself, that's B squared, and that would give me this area. 4 times 4 is 16. It is equal to this side, which is C, and if I took this side C, which is a length of 1, 2, 3, 4, 5, and I did 5 squared, or C squared, I get that big area that's equal to these two areas added together. Okay, so now I'm just going to fill it in with numbers so you can see the side of this leg was 1, 2, 3. So I've got 3 squared plus side B is 1, 2, 3, 4. So that's going to be 4 squared to get that area, 4 times 4. On side C, the hypotenuse, I have a length of 1, 2, 3, 4, 5. I'm going to square it because the formula tells me to. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And whenever I add this side right here, 9 and 16, I do get 25. Okay, so we've got a picture showing you what the formula is about. The area of these two squares is equal to the area of the biggest square. We've got the formula with some side lengths plugged in so you can see it really is equal. Okay, so now we're just going to write out in words. for a right triangle, if you add the areas I don't know if I started that the way I wanted to. For a right triangle, if you add the areas attached to the legs, then it will be equal to the area by the hypotenuse. Okay, for a right triangle, if you add the areas attached to the legs, then it will be equal to the area by the hypotenuse.